So you are welcome to today's class. So we want to look at circle, equations of tangent and normal. You will recall in our last physical class that we talked about the general equation of a circle, which is represented by this equation: x squared plus y squared plus 2gx plus 12y plus c equals 0. And where we said that if this if the center of the circle here is moved to the origin O, okay, the coordinate of this origin, where the coordinate of this origin is 0, 0, okay. If we move this circle to this, where the center of the circle is now 0, 0, okay, we have said that this equation will be reduced to this form, okay, where G in this case is represented by minus A, which is the center of the circle, and F in this case is represented by minus B, which is also the center of the circle. Okay, and this radius, when compared with this, okay, can be gotten as this formula. Okay, this is what we have done in our last physical class. So today we want to look at uh, tangent or equation of tangent of a circle. You will recall that if you have a circle, we have said there will be what we call the coordinate of the center, which is represented by A, comma B here. And there will be what we call the radius, which is the point from here to here, the point from the center to a point on the circle. Okay, so a straight line that touches the circle at one point, I call a straight line such as this that touches the circle at one point and perpendicular to the radius line is called the tangent line of the circle. So in this case, you will see that this line has been drawn in such a way that it is perpendicular to this. Perpendicular in the sense that uh, yes, perpendicular in the sense that this line form an angle of 90 to this line. Okay, so in this case, this line is the tangent line of this circle. So the point of contention here is that how do we represent the equation of this line? Okay, you will recall in our last two physical classes, we have told ourselves on how to write or deduce an equation of a circle, an equation of a straight line, such as this. So yeah, what we want to look at here is to know how we can find the equation that will be representing this line. Okay, so from this equation I will have here, either this or this. Okay, let's start from here. Okay, how we can generate uh, equation of a circle when the circle is at the origin, and how can we generate the equation of a circle when it is not at the origin. Okay, so this is two things now. When the circle is at the origin, how to generate the equation of the tangent line, and when it's not at the origin, like a circle of the sun, how can we generate the equation of this line? Okay, so let's start with this. Okay, so this is taken So we say consider the equation of the circle at the origin. Okay, we said it's at the origin because the center of the circle is 0. The coordinate of the center is 0, comma 0. Okay, so what we want to deduce here is to uh, look for a tangent, the equation of a tangent line. And before we do that, the first thing is to know what is the slope of the circle. Okay, this we so after knowing the slope of the circle, okay, so we can now form, this will tell us how slopey is the tangent line. Okay, the tangent line that touches the circle at one point. Okay, it will tell us, okay, how slopey is the line. Then secondly, we'll now state a point at which the line is touching the circle. Okay, so these two things will constitute uh, an equation, okay, that will be representing the equation of a tangent line. So that's how we do this. So from here, if we differentiate, so I'll revert this to this as equation 2 here. So if we differentiate 2 implicitly, okay, so if we differentiate this implicitly, okay, so this will be 2x plus 2y Okay, sorry for that. Sorry for that. So I muted the video earlier. So what we are trying to say here is that if you have an equation from the origin, okay, and we are trying to get the slope of the circle, okay, we can get that by differentiating this implicitly as this. From our knowledge of calculus, we are able to do this. And then after, from here, if we differentiate this with respect to x, we have 2x. Differentiate this with respect to y, okay. So here we know y is depending on x. So anytime we differentiate the variable y, that will come with the y ds, okay. And r here is radius, which is a constant. So when we differentiate that, we have 0. So dy ds here is the slope of the circle, okay, or tangent, as the case may be. So if you let m to represent this dy dx, okay, so we have m equal to this, okay. So like we are making dy dx a formula from here. So when we make this a formula, this is what we get, okay, where m is the same as the slope dy dx. Okay, so here 2 cancel 2, so we have this. So now we said if the tangent line touches the circle at the point s1, y1, then the slope becomes m equal to this. Okay, so from here we cannot get the equation of the circle at one point. So we cannot get the equation of the tangent line at one point. So we say therefore the equation of the tangent at the point x1, y1 is given by y minus y1 equals to m x minus x1. Okay, so we recall in one of our physical classes, okay, we have talked about something like this. That's when we want to represent equation of a straight line when the slope is known and the point at which the line passes through is known. Okay, that's the case there. Okay, so now, so by replacing this m with the slope we have got from the equation of the circle, so this becomes this. Okay, so without solving further, this equation, or if you resolve this, you can make this to be y1 plus xx1, okay, yes, equal to when we resolve this, we can get an equation where this will be equal to r squared, okay, something like this. Okay, we can resolve this to make something like this. Okay, so where y1 is known from this point, x1 is known from this point, and of course r is the radius of the circle, as we have already known. Okay, so if we resolve this, we can get something like this back. Okay, so that is that on this. So we can now make a conclusion from here that this equation, either this or this, so is the equation of the tangent line. Okay, this equation of this is the equation of the tangent line at the point x1, y1. Okay, So the next thing is to deduce the equation of the tangent when the circle is not at the origin. Okay, so we'll make use of the general equation of a circle as we have earlier shown there. So consider the equation x squared y squared plus 2gx plus 2fy plus c equals 0. Okay, so we'll recall that this is the equation of a circle, or the general equation of a circle, when the center is not at the origin. Okay, what we have shown here is a equation of a tangent line when the circle is at the origin. Okay, we want to show for the one which for a case of a circle whose origin is not equal to 0, 0. Okay, so the same thing, we differentiate this implicitly to get the slope dy dx. So again, we'll make that slope to be the letter m. Okay, after which we will now substitute such slope into equation whose equation of this form. Okay, so we'll see that the only difference will be that this term and this term will be removed from the change in x here will be removed from a term. Okay, different from the origin. Okay, so that will be the only difference there. So let's see this. So I want to differentiate this implicitly. Okay, this will be 2x. Okay, 2y dx. Don't forget, we are differentiating this implicitly, just the same way we have done for the first first form of equation of a circle. Okay, so this is x. If you differentiate this will be 2g. So if you differentiate this will be plus 2f. Okay, because a term of y is here, this will be coming with dy dx. C here is a constant, that will be 0. So everything will be equal to 0. Okay, so here we'll bring all the terms with dy dx together. Okay, group them together because what we're looking for here is dy dx. Okay, other terms will be taken to the other side. So as you can see, we'll see that 2 is common in all of the terms in this equation. Okay, it means we can divide through by 2 so that all those 2 will go. So if you divide through by 2, so all this will be then group collect terms that are alike. The terms that are alike here are y plus f dy dx, and this will be equal to minus x minus g. Okay, so here we are looking for dy dx. Okay, so we say dy dx, which is the same thing as dy dx, be equal to minus x plus g all over y plus f. Okay, so this is the slope of the equation of a circle that is not from the origin. Okay, similarly, if we are to derive this equation at a point where the tangent line, where at a point touches the circle at x1 y1. Okay, so this x here and this y also become x1 y1. Okay, so let's deduce that from here. So again, at x1 comma y1, m, which is the y dx, will be equal to minus x1 plus g all over y1 plus f. Okay, so you see that the only difference between this slope and this slope here is that this g and f are 0. Okay, if g is 0 and f is 0, okay, we solve as equation of this form. Okay, so you should see that now that these are similar. Okay, so now, so the equation of the tangent line so we will be of this form. Okay, but instead of this slope, this will be so instead of this slope, this will be y minus y1. Okay, we are representing this slope with this m. So this will be minus x1 plus g all over y1 plus f. Okay, x1, okay, x minus x1. Okay, so again, this is the equation of the tangent at the point x1 comma y1. Okay, and we can write this through in a straight form, and this will be, we can leave this like this, or we can solve further to get y1 plus x1. Okay, you can start with this. Okay, let's start with x. x1 plus y1 plus g okay, so that is, if you resolve this, we'll get this. So either this or this is the equation of the tangent line at the point s equal to x1 y1. Okay, so either this or the previous one are used to find the equation of the tangent line. Okay, so what we are saying in essence is this. Let us explain this using the diagram here. Suppose we have a circle, and the center of the circle is the coordinate of the point AB, and then what you are saying is that this point, okay, where the tangent line touches the circle has the coordinate x1, y1. Okay, so what it means is that we can get the slope of this line, okay, by getting the slope of this. Okay, and of course, this is perpendicular to this. Okay, so the equation of this line, the equation of this straight line is this. Okay, so in the case where the center of the circle is the origin 0, 0, okay, we will have the previous equation of the tangent line that we get earlier. Okay, so this is how we deduce this. So as you can see, we want to talk about two things here: the tangent and the normal. Okay, so from this circle, how do we get the normal of the circle? Okay, so if you want to get that, when we say normal is this line. Okay, that is perpendicular to the tangent line from the center of the circle, okay, or from the origin of the circle. Okay, so now to get that, you see that this line that is cotangent, okay, is perpendicular to this line, okay, the line that we call the normal line. Okay, you see that both of them share the same point. Okay, they share the same point. Okay, and again, this line form a right angle triangle with this line, with the tangent line. Okay, so it is possible for us to know the length from here to here. Okay, and of course, for some given parameter, we can determine from here to here and then from here to here. Okay, so from here, we now say since the slope of the tangent, let m equal to m1 here be the slope of the tangent line. Okay, and let m2 be the slope of this so let m2 here be the slope of the line perpendicular to the tangent line. Okay, so the slope of this line, we have said previously it is m, and we say let that be m1. Okay, which in this case m1 is the slope of the tangent line. And again, for this second line, we say let m2 be the slope of the line which is perpendicular to the tangent line. So in this case, since this line and this line are perpendicular, okay, we have already shown that if this happens, this m1 will be equal to negative of this. Okay, so we make a conclusion like this, and then this m1 in this case will be equal to this for the case of perpendicularism. Okay, so in this case, the equation of the normal to the circle at, when I say circle, I'm referring to the general equation of the circle that was given earlier. Okay, at x1 y1, okay, will be something like this also. Okay, but in this case, this will be m2. Okay, this will be m2 since the tangent line and the normal line touches the circle at this point. Okay, so this m2, okay, of course, will be, if you make m2 a formula here, you know m2 will be equal to this. Okay, initially what we have got here is the m1. So if you reverse this, okay, we can get this form as our equation of the tangent of the normal line. So this will be y1 plus f all over x1 plus g. Okay, so if you make m2 a formula and then we'll bring m1 to this place, okay, we'll get m2 to be this form. Okay, so this equation that we have got here is the equation of the normal line, okay, at the point x1 comma y1. Okay, so we have been able to deduce 3 or 4 things there. So also from here, if we can reduce this normal line to equation of the normal line of a circle of a circle at the origin. So in this case, the point or the coordinates f comma g, if it is 0 comma 0, okay, this will reduce to that form. Okay, if the coordinate of the center is 0 comma 0, okay, what we have will be that you see this will be y minus y1 equal to y1 over x1. This will be into this. Okay, this is also the equation of the normal line, okay, at the point s1 comma y1 of an equation of a circle whose center is at the origin. Okay, so here we have been able to deduce 4 things. Okay, so the first 2 things is we have talked about 2 general equations of a circle. The first one is a circle at the origin. We have been able to deduce both equation of tangent and normal for a circle at the origin. Okay, you have given one earlier. Okay, and the second one is the one we deduced here. Okay, secondly, when we have a general equation of a circle whose origin is not 0 comma 0, okay, we have said we can deduce that of the tangent, okay, to be the one we give earlier, and then we have said that of the normal will be this equation. Okay, so those are the 4 types of equation we have deduced under here. Okay, so before we go into giving some examples, let us look at some of the things we can note right from the tangent and normal of a circle. Okay, so let us from the board. So if you have any question, okay, feel free to comment on the comment section. So I will respond to you when I'm through. If this has been taken, so I can wrap this up. So I want to note 2 things from here. So the first thing I want to note is that the tangent to the circle is perpendicular to the radius. Okay, so let's have the diagram here so that when we are making such a comment, one can vividly look at this and then compare that. Okay, from here to here is the radius of the circle. This is the coordinate of the center. Okay, and this is the tangent. This line is the tangent. That's the tangent line. Okay, so what you are saying is that the tangent to the circle is perpendicular to the, as you can see, this line here form a perpendicular line to the radius of the circle. Okay, the radius of the circle. Okay, so you can see the point of contact is this. So that is the first thing we want to note. So the second thing to note is that if two lines, suppose this is a circle, and there is a tangent line here. This is a tangent line to the circle. This is also a tangent line to the circle. So if two tangent line, okay, touches an external point like this, okay, such that we can really line like this. This line are two tangent line, as you can see. This one is touching the circle at this point, and this one is touching the circle at this point. This is the center of the circle, and this is a specific point. Let's say point P. Okay, these are two tangent line touching an external point. Okay, so if this happens for any circle, as you can see, because the radius will be the same. These radius are the same. What it means is that these two tangent line, okay, they are the same. Okay, so if you can form something of this form, so we'll say that these two tangent lines are the same. Okay, so what we want to say here is that if two tangent lines are drawn from an external point of a circle, okay, then the tangent lines are equal. Okay, that's the second thing we want to know. So yeah, as you can see that they are the same, including the radius and the same. This line, okay, which from a hypotenuse line to this to this line, the same hypotenuse for this line. Okay, so that is two things we want to note here. So let's see some examples. But before examples, I would like to know if you have any questions. So any question? Feel free to write your questions on the comment section. Okay, somebody is asking that what are the general equation of a circle? Okay, so thank you for the question. Okay, so if you have the circle of this form, okay, where the center of the circle is this, okay, and the radius line is touching the circle at any point x, y. Okay, so we can from here we can generate what we call a standard form of an equation of a circle. Okay, using the equation of a line joining 2 points. Okay, so we see that this forming a right angle triangle, and from Pythagoras theorem, this is r. This r will be r square equal to x minus a. Okay, let me do that properly so that one can get what you are doing easily. This is a point a, this is a point x. Okay, the distance from here to here is x minus a. Okay, and the distance from here to here is y minus b. Okay, so from this diagram, you can get the standard equation of a circle, uh, which can be given as this. This is x minus a square plus y minus b square equal to r square. Okay, so this is standard. Okay, so from this standard equation, we can get the general equation of a circle. Okay, so from here, if you open the bracket here, this will be x square minus 2ax plus a square. We're expanding this to get the general equation of a circle. So if you expand this, this will be y square minus 2by plus b square equal to r square. Okay, so if we group this into a unique form, I say unique form in the sense that just to write it in a compact form in such a way that it will be more presentable than the way it is here. Okay, there are not of negative numbers here. Okay, so let's make some reduction here so that one can have. So same equation, we want to rewrite it. So if you write this equation as x squared plus y squared, x squared plus y squared, then this 2 minus 2a, okay, let it be plus 2g, okay, and so here we are only replacing minus a with g, and for this also we are replacing minus b with f, so that this will be plus 2fy. Okay, all other terms left there, you will see that all other terms are plus a square plus b square minus r square. Okay, so everything here, you see, let it be c. So if everything here is c, okay, those are the terms that are left there. Okay, so that whatever is there will be c equals 0. Okay, now say where the coordinate minus a comma minus b is the coordinate g comma f, and c is equal to, as we rightly showed earlier, this is a squared plus b squared minus r squared. Okay, so this equation is referred to as the general equation of a circle. Okay, and it's from this equation I think we started looking at the tangent line, the equation of the tangent line, and the equation of the. So in this same equation, though I think I've answered the question, let the person reply, please, if I've answered the question. So this is the general equation of a circle. So of a circle at any point a comma b. So if the center of the circle is 0 comma 0, okay, this form will be reduced to a form this will be reduced to this form. This will be reduced to this form. Okay. So where a comma b is 0 comma 0. Okay. So this is the general equation of a circle at any point a comma b not equal to 0. This is equation of a circle at the origin. At the origin means the coordinate of the center is 0 comma 0. So, and we have in this class look into the the equations of tangent and normal for this equation, and equation of tangent and normal for these equations. So that's the thing we have done. And we are on the stage where I want to consider examples before I say questions. So let me know if I have answered the questions. Okay, also Azan, you say yes, sir. You say thanks. Okay, and that has been answered. Okay, so now let's look at some examples there. Okay, so we'll be given the general equation of a circle. I'll be looking for how to get the equation of the tangent and equation of the normal. Then from there we'll look for some various examples here. Okay, example: find the equations of tangent and normal to a circle x squared plus y squared plus or minus 2x minus 4y minus 4 equals 0. So after getting the coordinate center, that will enable us to get the slope of this line. Okay, after we get the slope of this line, we make that m1, and then we get the slope of the second line, we make that m2. Okay, having get the two slope, so we can now form the equation, okay, from on this point. Okay, so let's quickly see that. So let us write this. So we are given x squared plus y squared minus 2x minus 4y minus 4 equals 0. So from here, you know that g comma f is equal to minus a minus b. Okay, so that happens. Okay, we can also get the radius r from this equation, a square plus b square minus c. Okay, so if we are able to do this, okay, so we'll be able to do. So let's see this. So when we compare this, what we see is that this 2g is equal to minus 2, and 2f is equal to minus 4. And here, this implies g is minus 1 and the f here is minus 2. Okay, so what you now have, so therefore, okay, so if you compare this with this, so we see that 2g is the same thing as minus 2, and 2f is the same thing as minus 4. So from here, we can get g and we can get f here to be this. So replacing g and f here, okay, so we have something of this form. So here we can see the coordinate of the center is 1, 2, just as this. Okay, so having done that, now move on to the slope of the tangent. Okay, and in this case, we call that M1. The slope of the tangent, we will say M1. Okay, and we have assumed earlier, we have shown that this is x1 or minus x1 plus if all over y1 plus f. Okay, this is what we have shown earlier. Okay, so from here we have that slope m1 is we are given this point to be, you will call that the point s1 y1 is 2, 0. Okay, so this is a minus 2 plus g here is minus 1 all over y1, which is 0, and the f here is minus 2. Okay, so if you remove this from here, everything here will be equal to this minus this plus minus this, that is 1. Okay, so minus 1 over 2. Okay, so negative here, so it means this 1 over, it means this 1 over 2. Okay, so m1 is this, which is the slope of the so I think this is taken. So also m2, which is equal to this okay, will be minus 1/2, and this is a -2. Okay, so you recall that this m1 is the slope of the uh, equation of the tangent, and this m2, which is -2, is the equation of the normal. So therefore, so therefore, the equations of the tangent and normal at 2, 0, okay, is the first one will be y1, y minus y1 equal to m1. So when we substitute, okay, you see this is s1 y1, and this is our m1. M1 is an average. So this will be y minus 0 equal to an half x minus 2. Okay, so if you resolve this, let's take this up. So if you resolve this, this will be equal to this will be equal to 2y minus x plus 1 equals 0. Okay, because when we open the bracket here, or you take these two to the side, okay, we take these two to the side, okay, this will be plus 2. It should be plus 2 in that case. Okay, so this will be plus 2. Yes. So this is the equation of the tangent. This is the tangent line. And also, for the normal, it will be y minus y1 equal to m2 x minus x1. And if you do this, you recall that our m2 is a -2. Okay, so this will be y minus 0 equal to -2 into x minus 2. So of course this is y equal to minus 2x plus 4. Or you write this as this. Or we say this is this. So this is the equation of the normal line. So this is the equation of the normal line. Okay, and that is that. Okay, so if we have question on this, okay, let's quickly look at that before we proceed. Okay, so I'll be checking the comment section. In the absence of question, I think we can proceed. Okay, so again, Okay, so you can take this as exercise. Okay, so you will record that this equation with circle is at the origin. Okay, so all you need to do is to obtain the slope of the circle. Okay, after which we will now, when we obtain the slope, we will now use that slope to get the equation of the circle at one point, 2, 2. Now at this point, for the tangent and the normal at this point. Okay, so one can take that as exercise using the formula, the two formulas we generate from the equation of the circle at the origin. Okay, so let us see one example that is not related to finding the equations of the tangent of the line. Okay, this equation is on uh, so this has been taken. So example 3. So if line AB is the tangent of a circle, okay, with center O at A, okay, so So this is what we are seeing here. Suppose we have a circle. Okay. Let's say the circle is has a line AB. Okay. Something of this form. This is line AB. Okay. And we are told that we centers to of radius 6 centimeter. Okay, if the center is O at A and the radius is 6 centimeter, so it means the length from it is 6 centimeter. Okay, again, we are told that suppose it means the line OB, okay, for which OB is 10 centimeter. So if this line means the line OB and this OB is 10 centimeter, okay. So we are now asked to find the length of AB. Okay, we have to find the length of AB. Okay, so to do this, I think this is not far-fetched. So since we know that the line AB is a tangent line, okay, it means this line form an angle of 90 to this, okay, which means that the shape you have got here is a right angle triangle, okay. And we can now use the formula which says that's Pythagoras, which says the square on OB, okay, is equal to the square of on OA plus the square on AB. Okay. So since we are looking for AB, I'm going to do this to make the line AB formula here. So once we do that, okay, this becomes this. If you make this a formula, it means this line is coming to meet this. So this will be OB squared minus OA squared. Okay. So when we substitute the formula, the term that we have got here, so we have told that OB is 10, which is 10 squared, and the OA is 6 squared. Okay, so this means 10 squared is 100, this is 36. So when you move this from here, that will be 64. Okay, so take the square root of 64. Okay, it means the length of AB is 8 centimeter. Okay, so this is just telling us on how to get the length of the tangent line. Okay, so these are some of the things we look into here. Okay, in our next class, okay, let's stop here. So in our next class, we look at parabola, equation of a parabola, tangent and normal of a parabola. So if you have any question, okay, so feel free to do that before we leave. Okay, or after the live video, you can comment your question, so I will attend to them.